Standard 10 Mathematics Part 2 Chapter Trigonometry. In understanding Trigonometric Identities in video number 5.
Now children, that we know that trigonometric functions, the basic functions sine, cos and tan can be applied for any right angle triangle, but for which internal angles? For the two internal angles. Which were the basic trigonometric functions? They were sine, cos and tan. These three basic functions could be applied to any one acute angles in a right angle triangle. Which are the acute angles over here, children? Those are angle A or angle C. So we can find out sine of angle C, cos of angle C, tan of angle C. But over here, as we can say, that C has got the measure theta. So we can write down sine theta, cos theta, tan theta. Which were the multiplicative inverse ratios of the three basic functions? Those were cosec theta, sec of theta and cot of theta. With reference to this particular triangle drawn on the board, let's write down the values of these 6 ratios. Sine of angle theta was opposite side upon hypotenuse. So that was AB. The hypotenuse is AC. Cos of theta. This particular angle is adjacent side upon hypotenuse. That is BC upon AC. Tan of theta was opposite side upon adjacent side. That is AB upon BC. Let's move on to write the reciprocals, the multiplicative inverses of all the three. The multiplicative inverse of sine theta was cosec theta, which gives us by the formula hypotenuse upon opposite side. So AC upon AB, just its reciprocal, AC upon AB. Sec, as it is the inverse of cos, it will be hypotenuse upon adjacent side. So sec of theta will be hypotenuse upon adjacent side, AC upon BC. And the inverse of tan was adjacent side upon opposite side. That is BC upon AB, just its reciprocal, BC upon AB. So, how do we now get the trigonometric identities? Let's find out. To get the first identity, children, let's apply Pythagoras Theorem, as this is a right angle triangle. What does Pythagoras Theorem tell us, children? It is the sum of the squares of the two sides making up that right angle is always equal to the square of the hypotenuse. That is the statement of Pythagoras Theorem. Let's convert it to with reference to the right angle triangle. So the sum of the squares of the two sides making up that right angle. Which are the two sides making up the right angle? One is AB and one is BC. So AB squared plus BC squared is equal to, by applying Pythagoras Theorem, AB square plus BC square is always equal to the hypotenuse square. Which is the hypotenuse over here? It is AC. So that will be equal to AC square. Now children, how do we get the trigonometric identity? By using Pythagoras Theorem. Let's divide the whole equation by the hypotenuse square, that is by AC square, and let's see what do we get. So AB square, each term, children, we are dividing by AC square plus BC square upon again AC square. Whatever you do on the left hand side should also be done on the right hand side. So AC square upon AC square. So by dividing AC square in equation number 1. So which was the equation number 1? Right? Now what do we get? Here we can see on the right hand side it gets reduced. AC square and AC square gets reduced. Let's look over here, children. AB square upon AC square can be written as AB upon AC the whole square. A square upon B square can also be written as A upon B the whole square plus the second term can be written as BC upon AC the whole square, which is equal to, on the right hand side what happens, children? AC square and AC square gets reduced. So what is on the right hand side? The answer is 1 upon 1, which is 1. Now children, let's, with reference to whatever we have got on the left hand side, compare it with all the ratios that we have already written. Do we have AB upon AC? Definitely. What was AB upon AC? It was sine theta. That means for AB upon AC, we can substitute the trigonometric basic function as sine theta. But what is it? It is square. So what will we write? Sine of theta the whole square plus, let's move on, BC upon AC was which trigonometric basic function out of these 6? It was cos of theta. That means for BC upon AC, we can substitute it with the trigonometric basic function, that is cos of theta. Cos of theta the whole square. Let's not forget it, which is equal to the right hand side, that is 1. So finally children, what are we getting over here? Sin theta the whole square plus cos theta the whole square is equal to 1. In other words, we get the first trigonometric identity. That is sin theta the whole square can be written as sin square theta plus cos theta the whole square can be written as cos square theta, which is equal to 1. This is the first trigonometric identity. So what did we conclude? We concluded that sin square theta plus cos square of the same acute angle is equal to 1. Now children, this was for one acute angle. This identity can also be applied for the other acute angle. Which is the other acute angle over here? The other acute angle is angle A. So definitely we can write sin square A plus cos square A is equal to 1. But as angle C is given as theta, what is the measure of the other acute angle? Definitely when the sum of both these acute angles is equal to 90. If one angle is theta, the other one will be 90 minus theta. Let's write down the first trigonometrical identity for the second angle, which is acute. That will be sine square of, now we are changing our reference angle from theta. We are writing the first trigonometrical identity for the second acute angle. So which is the second acute angle? 90 minus theta. So sine square of which angle? 90 minus theta plus cos square of which angle? 90 minus theta is equal to 1. This is the trigonometrical identity used for the second acute angle in the right angle triangle ABC. In other words, children, we can write sin square A plus cos square A is equal to 1, or sin square 90 minus theta plus cos square 90 minus theta is equal to 1, or sin square C plus cos square C is equal to 1, or sin square theta plus cos square theta is equal to 1. So by using Pythagoras theorem, we were able to get the first trigonometric identity. Sin square theta plus cos square theta is equal to 1.